All right. We are going to record a video of the practice test answer key. Myself and Ms. Howard are both going to do it. So I will post it as page 1, page 2, and you can look at it to study for your test. So whenever you're answering a question with the pH of a solution, you're supposed to look at the hydrogen ion concentration and the number that's given to you. Do you see the -6 here? That means if it's -6, the pH will become 6. Alright? So you circle 6. So now if you look at glucose's formula, it's C6H12O6. Do you see the numbers 6, 12, and 6? Can you divide them by 6? Can you divide each one of them by 6? So what do the subscripts now become? It becomes 1, 2, and 1. So you will circle 1, 2, and 1. So now let's look at the next problem. Now this is a stoic problem because they have given me water and they've given me liters of water and they want to go to liters of oxygen. So the way this problem is done is, what you will do is, you will convert liters of A into moles of A, into moles of B, and then into liters of B. So you are given 4 liters of water. What do you convert into moles of water? And then you have to cancel out of liters of water. And the number that goes before liters is 22.4 is 1 mole of water. I bring down moles of water. Now I am in mole A, so I have to go to mole B, which is moles of oxygen. And I get this from the mole ratio that's in the equation. Water is 2, oxygen is 1. So I'll substitute 2 and 1. And now I have to get rid of moles of oxygen. And I have to convert it into liters, which is again 22.4 liters of oxygen. So liters of oxygen will actually cancel out. So all I'm left with for my math portion is 4 divided by 2, which will be 2. So my answer will be 2 liters of oxygen. This is how you do a stoic problem, which goes from liters to liters. Now let's look at this problem. So here is a gas tank and it contains nitrogen and it contains oxygen. So the total pressure is the added pressure of these two gases. All right? So P total is going to be 2.0 plus 5.0, but this is only 7 atmospheres. They have said that the total pressure in the tank is 10 atmospheres. There should be a third gas, and let's say it's not oxygen. Let's say it's another third gas, helium, and we want to know what's the total pressure of helium. So the way we would do it is that we have the total pressure is 10 atmospheres, and we would subtract out 7 atmospheres from it, which leaves us with 3 atmospheres. So there isn't 2 gas, but there are actually 3 gases. So it contains nitrogen, oxygen, and helium. And we are finding the partial pressure of helium, which is going to be 3 atmospheres. Okay, so now let's look at the next problem. This is the substance that's starting with hydrogen. So that will be your acid. Anyway, if you look at the product side also, you can see that the hydrogen is going from this substance to that substance. So that will be your acid and that will be your base. What does the base become? The base becomes the conjugate acid. What does the acid become? It becomes the conjugate base. So right now we are asked to identify the conjugate base, and in this case the conjugate base is your Cn minus. So this is a half-life problem. So we have a starting amount of 600 grams and the ending amount is 150 grams. So the way I'm going to do this problem is I'm going to set up a T chart and I'm going to say at 0 it was 600 grams. When it first divided, it became 300 grams. When it divides next, it becomes 150 grams. So each time I'll just divide by 2. So this 600 grams was at 0 time. When did you get to 300 grams? At 25 minutes. So if you add another 25 minutes, it becomes 50 minutes. So when did it become 150 grams? At 50 minutes. So you can circle 50 minutes. The other way to do this problem is it divided 2 times. So you have total time by half-life equals 2. And then your half-life is 25. So 25 times 2 is 50. That's another way to do the problem. So let's arrange these elements as they appear in a periodic table. So you have strontium, followed by indium, followed by antimony, followed by iodine. So what happens to ionization energy as you go across a period? It becomes bigger and bigger. It increases. And so they want to know which is the largest, and you will circle iodine. Let's come to the next problem. So here is a gas, and the units of pressure is millimeters of mercury. They want you to convert the unit from millimeters of mercury to atmospheres. So the way you do this problem is you set it up as millimeters of mercury. You will cancel out of millimeters of mercury, and you want to convert it into atmospheres. The conversion factor is 760 millimeters of mercury is 1 atmosphere. So if you divide the numerator and the denominator, your math in this problem will be 1550 divided by 760, and if you divide, you'll end up getting 2.034. Now, if you look at the last problem, you are given volume, which means it's V1. You're given pressure, which is P1. Then this is V2. So you have the combined gas law, which says P1, V1, T2 equals P2, V2, T1. But there is no temperature in this problem. So you can just get rid of the temperature, and your equation is just P1, V1 equals P2, V2. Now substitute in the equation 2.25 times 3.45 equals, your volume is 3.75, and you're solving for P2, which is your X. So you'll divide both sides by 3.75, and then you'll get your answer. If you substitute it into your calculator, you'll get 2.07 atmospheres. Now I know that I started solving the problem without reading it. What you guys can do is you can read the problem, pause the video, and then start the video to be able to answer your questions. So video, second page practice.